Okay. Hello everyone. Now I'll be showing you the demo of our project BlockEstate 360. Firstly, sign up. I'll be choosing seller or agent. The login credentials will be stored in the MongoDB itself. As you can see here, abs@gmail.com, and the password will be encrypted. In this review one, mainly we have completed the price prediction. Firstly, the manual input. Here we have taken Bangalore dataset, that is Bangalore house price dataset, um, which consists of 13,320 rows and 13 columns approximately. And for example, here if I give location as Whitefield and square footage 1200, bedrooms will be 2 and bathrooms will be 2. The predicted price will be around 78 lakhs. And again, if I change this as 3 bedrooms or okay, 3 bathrooms, and the prediction will be more. It will be proportionally increasing according to the input with the price. And this is about the demo. In Here you can see the housing data set consists of this much of rows and the columns. Moving on to the presentation. Our topic is AI powered smart real estate tracking and secure transactions on blockchain. Firstly, algorithm design and correctness validation. And these are the contents. Structured and documented steps. Data loading. It reads the data set, that is, it will load the data set. Here we have taken Bengaluru house prices. It will be loaded into the Python, that is, here we are using the Flask. So the Flask we are using because it is a simple framework. And if we are here we are loading the data set because at a single central point we will be able to access those features and can predict the price. This is about the data loading. And then the data cleaning and pre-processing. uh, in this process, it drops missing values to avoid inconsistent records. And also, for example, if the dataset consists of any of the values like in the form of range, as you can see here, 1200 to 1500, it will be converted to a single range. And the non-numeric forms, here square meter, it will be only considering a numeric part, that is 34. And a single column will also be made, that is price per square feet. And here 2 BHK, as usual, the non-numeric part will be ignored and only the numeric part will be considered. Next, feature selection and transformation. It keeps only essential features. So in the data set, it consists of a lot of columns. It will not consider all the columns which doesn't affect the house price. It only consider those columns which affect the house price. And it applies one hot encoding on location. One hot encoding on location means in the location, for example, if the location it will be in the form of here you can see electronic city phase 2 or Uttarahalli. It will be in non-numeric form. It will be converted to numeric form. So, okay. Model training defines X features and Y, that is target equal to price. Here, inputs will be the features and the output, which is target. In our case, it is price prediction. It trains a linear regression model on the process dataset. It doesn't consider the whole dataset. It only consider a part of the dataset that affects the housing price. Next, efficiency, time and space optimization. Time complexity, linear regression chosen for simplicity and computational efficiency. So we have chosen linear regression model because of its simple algorithm, and it doesn't consume heavy memory. It is a less memory consumption algorithm. So in this case, it will help in time complexity also. And space utilization, it saves only the necessary model and metadata. As I told you earlier, instead of the whole data set, it considers only a part of the data set. And lower dimensional representation, dropping redundant dummy variables in the data set. Some of the redundant variables will also be ignored, and only the variables that is a part of the only that group will be considered. Further will be continued by Amulya DM.
Hmm. Okay, so let's come to the requirements and the edge cases of this project. The main functional requirements are it cleans and pre-process the raw housing data. It is very essential to have the clean data without any missing errors or missing values. And it handles the categorical features. Like for example, if we take the location, it will only give the it will just take the number format. It doesn't take like square feet like that. So it handles the categorical features by using the one hot encoding. It persists both the model and feature set for API deployment. Mm. So it saves both the model and feature list for the future use in the API development purpose. So these are the main functional requirements. When it comes to the edge cases, first it removes the rows with the missing values with a not of number form. It will remove the missing values. Then it handles the invalid total square feet entries, like if it is in the non-numeric form or in between the ranges, it will take only the number format. So it will handle the square entries correctly. Next, it prevents the dummy variable trap in one hot encoding. So it will remove the extra columns or extra rows to prevent the overloading. Then it ensures the input feature names which are consistently in lowercase when saved. So the input feature must be in the lower case so that it will do not get confusion or miscorrection in the input values. So the it is the main edge cases. So next.
Um, so here I am explaining about how to validate the output and test cases. In our project, the goal is to predict the property price accurately and reliably. But in real life, sometimes users might input wrong or incomplete data. So it's very important to make the system robust and fault tolerant. There are some test cases we are checking here. First one, very small or very large total square feet. If the total area of the house is unreasonably small, like 0 or negative, or extremely large, like 1 lakh square feet, these are likely data entry mistakes. If we reject such values or show a validation error because they don't make any sense. Second one is missing inputs like number of bathrooms, number of bedrooms, or square feet, which is required. If a user forgets to enter the number of bathrooms, bedrooms, or area, the system doesn't proceed with the prediction. Instead, it alerts the user to provide those essential inputs. Third one, malformed inputs. If the user enters text like ABC or any string in the area field, which requires a numeric value, we don't allow it. We parse the input, and if it's not a number, we return a clear validation error. Fourth one, unseen locations. Let's say the model was trained with locations like, example, Indira Nagar or Marathalli. Now the user enters a new location like Newton layout, which is not trained in the data set, which the model has never seen before. Instead of system crashing or giving an error, we map this unseen location to a special location type, that is location other, a dummy variable, which is set to 1, or treat all location dummies as 0. This way, the model still makes a reasonable price prediction based on only the numerical features like total square or bathrooms, bedrooms. This can be validated by using the one-hot encoding. One-hot encoding means the location feature in the data set is categorical, like text values like Indira Nagar, Marathalli, etc. The machine learning models like linear regression requires numerical input only. So we apply one-hot encoding during the data processing, which will convert each unique location into a separate binary column like 0 and 1. If the location we are entering is present, it will map to the 0, 1, or if the location is not present, which will be entered by the user, that will map to the 0. This way, the model learns how each location independently affects the property price and predicts the accurate price. These are the test cases we are validating here. Over to Alia.
Moving on to the resilience validation and error handling. First, we will be checking the schema check, whether it is in the first schema check, we will be ensuring the required fields are present or not, whether the number total square feet, the number of bathrooms, the number of bedrooms are present in a given data set. Next, moving on to the second step, we will be doing parse and normalize. So in this step, we will be taking a total square feet as an example. Then we will be comparing that total square feet within the single helper parse total square feet value. It is nothing but a parse total square feet is nothing but a value. We will be go on comparing with the total square feet. So in that we will be first accepting the numbers and the numeric strings. Secondly, we will be checking whether if it is ranging like 1200 to 1300, like some type numbers, we'll be making that into a mean value, and then we will be returning it. Then it will be recognizing the units, which will be, if it is given in a square meter, then we will be converting it into the square feet conversion, and then returning the lastly we will be returning none for the unparsable values, like which will be negative, lesser than 0, or equals to 0. Moving on to the numeric checks, here we will be checking the number of bathrooms and the bedrooms are given in a numeric form, whether it is neither a negative or lesser than 0, or that we will be checking. Next will be the sanity checks and the bounds. In the sanity checks and the bound, we will be checking whether the total square feet should neither cross the lesser than 50 or greater than 1 lakh for the unrealistic outputs or the tunable inputs. Then we will be going to the categorical handling. In the categorical handling, we will be checking the map locations, like dummy locations will be there in the column, or will be null values we will be checking out, and we will be filtering it through our training. Next, moving on to the algorithm. Here there will be the linear regression algorithm. So in the linear regression, we will be training the module through this model through this algorithm. Firstly, we will be taking care of this import numpy as np, which is nothing but a basic mathematical calculations we will be importing for this. And then we import matplotlib.pyplot as plt, and from sklearn we will linear model we will be taking the import we will be importing the linear regression. And here for the training data we will be taking two parameters, one is x and another one will be y. In the x value we will be taking some of the number of columns for the feature and another sum of the number of columns for the target. And then we will be training the model through the linear regression, and model dot fit x comma y we will be training here. And y predict, here we will be predicting the y value using the x features. So lastly we will be plotting some of the graphs for just to visualize how our training and the testing looks like. Moving on to the next, there will be equation and the mean square value. For the simple linear regression, which is nothing but one input feature, we'll be using y is equals to mx plus c, where y is the predicted output, x is the input feature, m is the slope, and c is the intercept bias or parameter, all that we will be taking care. And then we will be for the multiple linear regression, we will be using different formula, that is y is equals to w1 x1 plus w2 x2, so on to wn xn plus b. So this is the equation for the simple linear regression and a multiple linear regression. For the mean squared error, we will be taking care of this equation, and it is nothing but mean squared error. We will be considering this for a better accuracy in our training model. Thank you.